Good afternoon, everyone. We are finally here. I think that a couple of people are still coming in, so we expect to get more participants in a bit. While they don't get in, we will make a start for our webinar this afternoon. My name is Rodrigo. I'm from the Technical University of Denmark, and I'm going to be your co-host here today, together with my colleague, Sarah.
Yeah, I'm Sarah. I'm from Gate 21, which is a non-profit organization working with sustainable transition and is one of the leading partners of PowerBio.
Yeah, and before we start the content of the webinar, we have a couple of messages that we'd like to share with you. First of all, we are recording this webinar, so by participating here, you accept that it's being recorded. So the setup for the webinar is that we are going to have this little introduction, and then we will have 4 companies presenting different ways of utilizing biomass. And after that, we will have a close down with 2 very short last messages at the end. And during the presentations, you are welcome to make questions to the presenters. The presentations are going to be about 10 minutes, and then after the presentations, we'll have 5 minutes for a Q&A, for questions and answers. You're welcome to send your questions through the chat, and we'll be monitoring it all the time. We will ask you to communicate with us in the chat, because we plan to have quite a few people in this webinar, and if we open our microphones, it might be a little chaotic. So please feel free to contact us and send any messages in the chat. All right. Mm-hmm. And I think that was it for how the webinar is going to go. The motivation for this webinar, as you probably read in the invitation and in the registration, is a project called PowerBio. And Sarah, would you like to tell us a bit more about the project?
Of course. And I would just like to check the sound out there. So can you hear us? Could you maybe make a thumbs up if you can hear us? Or yes, perfect. Okay, that's great. That's good to know. Good. But yeah, let's move on to the purpose and what we are all here for today. Exactly that biomass is a valuable resource on the way towards increased sustainability. By establishing a circular bioeconomy, we can use renewable natural capital, thereby replacing the wide range of non-renewable fossil-based products currently in use. But before we even start harvesting these biomasses, we can make use of the biomass that is already available around us. Biomass that we sometimes give low value ends or simply dispose and consider waste. And these unexploited biomasses, they could be eelgrass, seaweed from the coastlines, it could be straw from agriculture, and it could be grass from the roadside clippings, amongst others, of course. And all of these biomasses, they can be turned into products of high value. And today, as you all know, we have invited global experts to tell us more about the best examples of exactly that. All right. So, as Rodrigo told you, this webinar series is part of a project called PowerBio. And in this project, more than 20 Danish and Swedish partners are developing, testing, scaling value-added solutions to increase the supply of biomass for green energy production and, of course, high-value products. So we are proud to bid you all welcome into our exploration of how the future market for circular bioeconomy might look like. Right, Rodrigo?
Exactly. That's exactly what Sarah said. And
but before we do that,
exactly, I was going to mention. So we'd like to have sort of an overview, or we'd like to know more about the audience that we have here participating with us today. So we'd like you to answer a quick poll that's going to pop up on your screen. We'd like to know where you come from. If you're from a startup, from an SME, what kind of organization are you joining us today from? And then we will make a wrap up about that in a bit. But this is interesting for us to have an idea of where you come from, what your interests are, which is something else that we'll ask you in a bit. We can see that there are people from different organizations, there are startups here, there are SMEs, people from research institutes,
municipalities.
So not-for-profit. So there's quite a diverse audience here today, which is very good. Yeah.
And we got 18 answers, but maybe
you can keep answering. Yeah. So we have about half of participants so far having completed the poll.
But there's a lot of different types here. We can see that, and people from a lot of different countries actually. We go on our participation list, right?
Exactly. Yeah. So, and something that we would like you to do, and please feel free to do so. You can go in the chat, write your name, the name of your organization, and the country you're coming from, and you can also tell us how you learned about this webinar. Was it on LinkedIn? Was it just by knowing Gate21 and going to their website? Was it by someone that it was just in your network and told you about it? We'd be very interested in knowing that.
Yeah. This is our pilot webinar today, so all the feedback we can get, we would really want that.
Exactly.
Yeah. All right. But I said complete on this one, and then we'll start another one.
Yeah. So we'd like to know the sector you work in or the interest that you have. So is it food? Is it feed? Is it materials? What is your main interest and why you joined this webinar today?
Yeah.
We would also like to highlight that, as I said, this is a pilot webinar. So we want to do a webinar series that will try to bring answers to the bigger question: what does a future market for a circular bioeconomy look like? And the first one is about utilization of different types of biomasses, right? So that's why we set up this one. But depending on the feedback that we get and depending on how interested it is for you, and we will ask you for your feedback so you can be prepared for it at the end. We would like to do more webinars if it interests you, and we would like to know what would be these potential topics that we could bring in future webinars.
Exactly. And now we got 18 answers here.
Yeah.
A lot of different areas. We got consumer goods, performance materials, quite a lot on energy and building materials.
Oh, that's interesting.
CO2 capture. Got a few on food as well. No feed farm or chemicals yet, though.
Okay. Yeah. And we can couple the answers that you just gave us, and you can also see these percentages here with the examples that we are going to have in just a bit. So as you can see in the next slide, this is the program that we have for today for examples of different types of biomasses. The first one, let's check if Daniel's there, but the first one is Daniel from EFLA. I'm not sure how to pronounce that. From Iceland. He's going to tell us a bit about how they used, or they are still finding out how to use excess heat to produce feed, animal feed. And then we have Christian from Kamita using grass to produce panels. And then we have Hyperlocal Hemp House with Peter, and he's going to tell us how we can use hemp in the building industry. And then we have from Brazil Mush telling us about different products that we can make from different types of biomass waste and mycelium. So we will ask Daniel, are you there? Just to check. Otherwise, we will ask Christian. Not yet.
Guess maybe not.
If you're there, you are very welcome to share your screen with us. You can take over and then you can start your presentation. Let us just check. Can I just ask Magnus's help? Can you check if Daniel is joining us so far? I think I can't see him here yet.
Term is here.
Sorry, what was that? All right, cool.
We just kept speaking, so we couldn't hear you.
Yeah.
That was maybe not the best strategy. Okay, but...
All right, so Daniel, feel free to share your screen, and then we'd like to hear from you. Are you there? Yeah. No, we can't see Daniel here. So in that case, Christian, would you like to go up first, and then we'll check on Daniel in a bit? Yes, please. So we'll have Christian. So you'll have 10 minutes to tell us what you came here to tell us, and then after that, we will open for questions. And then please feel free to write your questions in the chat, and then we'll voice them. So we'll try
Hello,
at the end.
guys. Do you hear me?
Yes, we can hear you.
Okay, so very good.
So the floor is all yours.
Thank you, Rodrigo. Thank you, Sarah, for this invitation and organization. With Gramiterm and market a unique thermal insulating batt panel made of fibers. Gramiterm started in Switzerland some 12 years ago, and I'm the founder and CEO of this business. So first of all, and this is the topic of today, what do we use as biomass? For Gramiterm, we use only grass from the nature. In other words, we don't use culture grass, and never Gramiterm product are in competition with the animal food sector. So these are some pictures. You can see we use grass from the roadsides. We use as well grass from the wetlands and the canal maintenance. We have a lot of wetlands in Belgium, and we valorize this biomass that is a waste. Okay, we have also some discussions now with municipalities, and we use as well grass from the airports cut. So that's the raw material. The beauty of this is that grass is everywhere in huge quantity, and this is a raw material. We don't need water, we have no irrigation and no human activity except cutting and collecting. Then what do we do with the grass? We will store the grass in silage. So we have some silage pits with this biomass. And then the deal is to extract the fibers from the grass. And to do this, this is a little summary of our process. We will separate the liquid from the solid. So with the liquid, the grass juice, we will use the grass juice containing all the digestibles, the proteins and sugar, and we will use that to flow into the biogas unit. And that will give us some energy that we will use later. And then we will stay focused on the cake, I mean the solid part of the grass, and we will wash the cake. We will put some additives for the fire retardancy system. And then the most important process is to dry the grass fibers. And to do this, we will use the biogas unit and the energy given by the grass juice. So in other words, at this stage, we use a grass that is coming from the nature. We store like the farming activities, and we will valorize as well the liquid and the solid part of the grass. This is a picture, a slide showing my plant or factory in Belgium. It is here a picture showing the grass fibers, the dry grass fibers, and we will mix this with some jute recycled fibers. So Gramiterm is 70% in the composition of grass fibers, and then we will add some long recycled jute fibers coming from the cacao and coffee bags from the Antwerp port. And we will add as well some binding fibers for the oven production. And this is the picture of the you know, the forming of the bat coming out from the thermobonding oven. Gramitherm is based here in Wallonia, in the south of Belgium, and we are based in a small village and having a 6,000 square meters factory. What is important is that we show, as thermal insulating solution, we show a negative carbon footprint. So this is the summary of that. And why? Because grass in the nature is the biomass having the shortest reconstitution cycle. Okay, so this is very, very fast to capture CO2, and there is no human activity, no pollution, and no need of energy. And then we have the last generation technology of Airlay, mixing fibers plant with very, very low gray energy in consumption. So 1 kilogram of Gramitherm absorbs, stores, in other words, 1.5 kilo of CO2 equivalent. So this is the best ratio in our product category. So we're listed on the Totem database. This is the official EPD from the product that we got this year. We are also now for 3 years in the database of France, INES, with all the environmental data sheets. And Gramitherm is now on the market since 10 years. And we have a European technical agreement delivered by the DIBT in Germany, Berlin. You will remember 4 points for the product. We have a wonderful insulation solution because long life efficiency. And this is because of a top of the class humidity regulation. The grass fibers has a unique capacity to take humidity, to reject humidity without any deterioration of the product. We are good to insulate it against cold as well as summer heat with a very good shifting time for a 240 millimeter thickness panel. We sell the product also, and we are proud to have air quality A+. So there is absolutely no VOC emissions, and we are a good sound absorber, very well appreciated by the wood structure and the construction. And we are as well a circular economy example, as we reuse the panels and the cuts of our panels on the job. We take them back to reproduce new panels at our factory in order to lose zero waste. This is some pictures about the outside and inside jobs. So you can see that we... Sorry? Hello? Hello?
13:23.
Christian, I think maybe someone just did not unmute their microphone, but please everyone unmute and then...
Nearly finished. You have some samples of our beautiful insulation job, inside, outside. These are the buildings types that we do. We do some, we like to be together with other biomass. So we do a lot of job with hemp blocks, with wood structure. So biomass is not just to be alone in the building construction, but this is really to be combined with other biomass product. This is for the fun. This is some houses that we made in Sweden, not far from Malmö, new construction for a residential business, entirely insulated with Gramitherm. This is a small movie I show you, and that will finish my presentation. So you can see here the grass cutting in the wetlands. This is the biomass we use. This is our production side, the airlay technology with the fibers, mixing the fibers. This is a picture of our product. Installation is very easy, no irritation, no mask, no gloves. And these are, just to give you some ideas, some building references that we do in Paris, in nearly everywhere in Europe, and showing that today the biomass and the bio-based product, we have access to a real building industry because of the humidity regulation, because of the negative carbon footprint, and because this is a long life thermal efficiency. This is a school we made this year. That is the end of my presentation. And we are very proud, all this team in Gramiterm, to have captured nearly 2,000 tons of CO2 because of our sales to the industry and the construction sector. Thank you, guys.
Very well. Thank you very much, Christian, for this exciting presentation. But before we go into the questions, let me just make a remark. There were some of you who couldn't log in. There was a problem with the link. We had to change the link due to network problems before today. So you might have tried to come in using an outdated link. So I think that was the case. So thank you, Christian. If you have any questions, please feel free to pop them in the chat. I have to make a comment before we get any questions. You mentioned that there is this the potential of capturing carbon because we're using biomass, but I think it's also extremely interesting that you mitigate other impacts as well. For example, you were talking about VOCs, right? The volatile organic compounds. You can also mitigate those. And if you replace, for example, panels that today are made from non-bio-based material, you are just mitigating a lot of impact. So there's a much healthier and safer option.
Yeah, that is the beauty of the biomass, Rodrigo, because I used to work in my past life for big industry producing mineral wool product, glass wool. And the question was for me, why do we need to use a high level of energy to produce a very simple product that has only one goal, to reduce the energy consumption? By producing glass wool, you need to burn sand at 1,300 degrees for 2 days. Okay, the Gramiterm panels will have exactly the same thermal efficiency, and we use a local resource that is not an issue like sand. There is no pressure on it, and we use oven at 100 degrees, 160 degrees Celsius, 2 minutes. So, well, we can insulate in the construction using local resources, local people, low gray energy, and that is a positive impact business and message. Okay, so it is time now to think a little bit different.
On top of all the environmental benefits, there's also the social and socioeconomic benefit, right? Because you're prioritizing local economy.
Yeah,
absolutely.
And we got some questions actually for you, Christian. And Eva, you also had your hand up. Maybe you can just write your question in the chat, and we will try to reach as many as we can. But Mette, she's asking, normally organic material will respond to humidity with mold. And then she writes, and are there any implication of using additive? Is it safe to return to the field at the end of life?
Yeah, because we use only mineral salt, natural mineral salt for the fire retardancy process. Okay, so that is the only additive that we put in our production process. And this is absolutely not a problem to recycle or reuse this after the end of life. Regarding the humidity and the molds and the fungi, we passed all the tests because we do extract all the sugar, all the proteins, all the digestible part from the liquid part going to the biogas. So the grass fibers that we use are really neutral and with absolutely no fungi development or humidity issues.
All right. All right. We got a few more questions. Michael, he's asking, how does your price, how do you price?
Yep.
How does your price of products compare to ordinary products? Sorry, that's my mistake. And Ludwig is also asking, is it competitive with other types of eco-building materials like hemp or flax?
Yeah, we are. So rapidly, we are cheaper than hemp and flax because there is absolutely no human activity or no culture. And this is the case of hemp and flax. They need to be cultivated. So a lot of energy activity. So we are cheaper. We are nearly, as a small business, we are today at the same level of price of the wood fibers. The big players in wood fibers, we are already there. And our main competitors are the mineral wool players, glass wool and the rock wool type of product. And we were 1 year ago more expensive than these guys, but because of the gas price increase and the energy price increase, I know that in Belgium now I got for the first time 2 weeks ago a first order from somebody, not convinced by the biomass, but I took the order because of the price. We were cheaper than the mineral wool product. So no, this is now booming because we are highly competitive in this business, and this is a good message. Ecology is the friend of economy. We can combine both. This is not to be with a good ecological balance and then out of the game because too expensive. No, we can combine both and develop products that are the new generation for the building industry and the construction.
Yeah, exactly. We see the very topics that we are addressing in this webinar reflected in your practice, right? Because it's local, it's bio-based, it's not just, it's also high value in many ways, because when we talk about the value of biomass, there are many different aspects that we need to take into account, right? So we can see that very much in the practice, in your daily practice, and that's very interesting. Thank you very much. We have still a couple of questions, but for the sake of time, I think that we will leave those questions perhaps to a one-to-one conversation that you might have by sharing contact, sharing your contact information and getting in touch later. Thank you very much.
Thank you,
Kristen. We'd like to stay chatting here forever, but we'll go to the next presenter. I think that Daniel is here now. So if you'd like to join us and share your screen, please take over, and you are very much welcome to start presenting.
Thank you.
And now we can see ourselves.
Yeah.
That's always nice.
And just so a last remark, we keep looking down, but we have our camera here, but we have our screen where we can see everyone participating in the webinar just down here. So we keep looking down so we can look at you. Yeah, so Daniel, the floor is all yours.
Yeah, I don't know if you can see my screen that is shared.
Yeah, we can see your screen and we can hear very well.
There we go. It's just it's slow here on my end. Yes. Well, sorry for being late, first of all, defunct link, but my name is Daniel Einarsson. I'm a mechanical engineer at Epla in Iceland. We're just a big company that does various projects, and we try to do mostly green projects. And for example, we are lead engineer on Carbfix and the new Coda terminal, where we will seek to reintegrate carbon into basalt layers with starting next year, but we're already in production. But I want to tell you about something completely different, which is a question on how do you use waste heat in remote areas, trying to promote circular ecology. And this project is where we're trying to make grass pellets for compound feed. So what do you do with waste heat when you have a lot of it? For example, what do you do if you have 130 degrees at 100 liters per second, or even hotter at more volume? And currently this water just gets mixed with cold water, so it can go into utilities. So it gets cooled down to 80 degrees Celsius, and so all of that energy is literally just lost. When looking at the potential use cases in this area, where you have this very sparsely populated and vast, then trying to look at the different industries, you have tourism. You could make another geothermal bath, but it wouldn't necessarily promote for any circular ecology. Fishing industry is large in this area and could be utilized, and so is other general industry. But where we've decided to focus was agriculture. And we could, for example, use this excess heat to develop, to promote growth of algae and then create biofuel. Or we could use other higher energy processes, which would need additional energy put into it, but to create a fertilizer. Or the path that we chose was to create compound feed. When we were looking at the very linear economy of compound feed today, it is all of the ingredients are imported from Europe and the States, and then it gets manufactured into compound feed, which we then push into animals, that we then consume whatever product they provide, and the bio waste that we have, wherever it comes from, usually just get pushed out to sea. So we have a very linear, non-circular ecology in this regards. And these numbers are fairly optimistic, trying to get a bit better view on my poor country. But what we try to do is look at how can we actually impose a circular economy on a very linear economy, and then mostly focusing on this, on how we get the raw materials into compound feed, and then using local ingredients and also getting local upstream ingredients to try to elevate the value of our grass. And then with very short conversations with local stakeholders in that area, we identified that, for example, we have a lot of waste spirulina from spirulina manufacturing, which is research that showed that it can, with just a minute amount in cattle feed, you can actually reduce the methane outlet that they produce. And there's a lot of seaweed in the area that is also not getting used. And we have biowaste from greenhouses in the area that is currently just dug a hole and it's put down there once a year. But a drying facility could, for example, lock in those values and get it into feed. Then finding the values in the local biomass and doing chemical analysis of the grass. When we look at this graph, you see the blue and the orange columns are compound feed that is produced out of imported materials, and the green bar is the same nutrients bought on local fields. Took a chemical analysis of 10 fields, and this is the average that we got. So with very minute, you can tune the grass to actually make a competitive product by adding local additives. And it's really important also to get local stakeholders get them on board, because it just doesn't work in in vacuum or by brute force, specifically in this in a really small conservative community. So almost from day one, when the idea got conceived of making cattle feed, was we incorporated the local farmer association, got them on board, and someone took control over my screens. Let me get back. Yes, and also getting the greenhouse growers on board and the energy company, so we can actually get access to this water, and the local politicians. And all of this has gone quite well so far. The future possibilities for this project could be, for example, is to develop protein juice from grass, and then we're not only providing protein or a nutrient resource to ruminant animals, but we can also start to consume it ourselves. And there is the university in Aarhus and ALA are working on a project trying to increase the yield that you get out of grass when you're extracting the juice from the pulp. Another project, which is also being researched at DTU, is phosphorus extraction from grass, which could also be very interesting because this is one of the big three when it comes to fertilizer. And when you have ample grass, then you could maybe try to, and also when you have a lot of free energy in quotation, then this could also be an interesting path to take on later. Yeah, but this is all of my thing. I tried to be quick, and now that it was late and we've also been dragging on. But any questions?
Yes, thank you very much, Daniel, for your presentation. I talked to you about this project a couple of times already, but every time that I talk to you that I know a little bit more, I have a couple of questions. But let's save my questions to the end if we have time. We have a few in the chat. Sarah, would you like to let us know?
Yes, and Daniel, it was not your fault being late. It was some trouble with the links, so don't worry about that. And we hope that all the ones who wanted to participate today are in the meeting now. We will, of course, we are recording this and we will send it out afterwards. So if you didn't get the whole meeting, you can look at it afterwards. Yes.
Awesome.
All right. We have one question here from Michael. How do you secure supply of waste heat, and at what cost?
Yeah, the cost has not been determined yet, but there are several pathways that can be taken. Currently, there are 2 points that where we can actually access this waste heat. One is a bit more remote, which is a large geothermal plant which produces, I think it's 90 megawatt hours, and they have, this is the 150-degree hot water at 200 liters per second, but and that would not be feasible. But where we want to get this hot water is at a local greenhouse, which is a hotspot area. They have more than 90 different drill holes. 6 of them are active, where you have hot water, and currently there's just a pipe going to the nearest town where it gets mixed with cold water. And it is local politicians have given a green light that we can access this water. And also the energy company is looking into how it is best for us to access this water. But the exact way how this will be done has not been determined yet, and it's just a matter of politics.
Okay. Yeah. Fair enough. And we actually, if we have time,
please,
we have maybe a final question here on the structure of the company. So will it be structured as a private company with some public-private partnership agreement? Michael is asking.
So so there is a long and a short answer for this, but I think the short one is that it was a very private project. It was a local investment group that started this in 2019, where they did exploratory report about this area, and now they are trying to get sell it, put it onwards. They have incubated the project enough, and they want to the whole one of the bigger ideas is also to get farmers in on this project, and to start to take them onwards in the value chain, and not just being a producer of raw material, but also actually producing a finished product that they can sell. And the state of the project now is that the investment company owns a certain amount of the company, but farmers are starting to opt in, and yeah. So, and ideally this should be majority locally owned by local farmers, this is like one of the key metrics that were stipulated at the start of the project.
Yeah,
so hopefully it can stay that way.
If I can ask a very quick question, which is very much related to what you just answered to Michael, but what did you use to convince? Because in your presentation you said that you need to build a local network, right? So what arguments did you use to convince these farmers or maybe other stakeholders that you will also need to make this a supply chain like that exists locally? Because it's not just like one company making this, but you also need people to provide other raw materials, and you need the facilities, and you also need a market for that. So did you have to use any arguments to convince this the building of this network?
Oh yes, there's certainly when going into a small community that is where the average age is higher than the norm, it is you're usually met by skepticism. But I would say the 50% of stakeholders were generally interested and keen, but that was the younger generation in general. But using history as a leverage was useful, because this is not the first time this has been done. Because in the 60s and 70s, Iceland we used to make grass cakes, and older generation remember this. But then that process stopped when oil prices started to rise, and importing materials from abroad became cheaper. Currently now they're just using diesel fuel to drive whatever they have, and so it is.
So there is a lot of cultural background that you also need to work with, right? So it's not just getting the facts and presenting, but there's also a lot of background that you need to
you're speaking to farmers
or convince people.
Yeah, you're speaking to farmers that live on a farm where you have a cemetery in the backyard with not just their parents, their grandparents, their great-great-great-grandparents. It goes back 200-300 years. So it is difficult. It is not. Some need a bit of convincing to see that they can maybe change some of their ways. They don't have to do everything as they do now.
Yeah,
they can specialize. Yeah.
Very well. So again, thank you very much for your participation. For the sake of time, we are moving on to the next speaker. I could again spend the whole afternoon, but I know that we will talk later, so it's enough for now.
Yes.
Thank you again for your participation. Yes, very much. It's our honor. Peter, I can see that you are here. So if you'd like to present now, you're very welcome to share your screen, take over, and we will hear from you. Let me know if you're able to take over and share your screen with us. I guess so. Yes.
Yeah.
Ooh. Is it working? Yes.
Yes, we can see your screen.
Let's see. Let's see here. Let's see here if you can see my screen now. And
I think we can see a mobile phone screen. Oh,
that is very technological.
That's very cool.
I don't know how to do that.
Well, welcome to Paris.
When you're from the House of Hem, okay.
Yes. Do you see my screen now? Because right now mine is still loading.
Yeah, we can see that it's loading yet.
Yeah.
Hopefully in a couple of seconds we'll see.
Thank you. Yes. So thank you for having me. I've been having some technical difficulties, as have you. From what I've heard.
Yes.
Yes, I just arrived from Norway yesterday. I am in Paris currently, and for about the 10th time this year, they decided to start digging up my street outside and cut off the fiber. So therefore, I'm on a mobile device trying to connect. So
Okay.
I'm hoping this will work.
Yes.
I don't know if you know.
And other,
Yeah, we can see it's loading.
otherwise, we could try to share.
Yeah. So you sent us your presentation, right?
Yeah, we have it here.
So if you'd
Yes.
like, we can share, and then you can just let us know when you'd like the slides to be changed.
Or you can
Sure.
take the.
Yeah, you can take over.
Yeah. Oh.
We will share our screen in a bit, and then you can use ours.
Actually, do you see my screen now as to this?
Yeah, we do. We can see it's not in
Okay.
presentation mode, but we can see that you have a slide.
Yeah.
Okay, so you see hyper houses at the moment?
Yes.
Now we can
Now
see it. Yes,
it's
it's in
good.
presentation mode.
Perfect.
Great.
Yes.
Feel free to carry on.
Okay, so my name is Peter Holmdahl. I work with Hempcrete Houses, and my goal is to create hyper-local markets throughout the world. And to start with, as we are talking about bio-based, I would like to describe why I'm working with what I'm working with and what hemp is and what hempcrete is. So when we talk about sustainability, we very often neglect the built environment, and it's a very odd thing to do because it is a huge part of our impact. 40% of all our CO2 emissions come from the built environment, as does 40% of our energy consumption, as well as 40% of our raw materials. So I will pose a question to everyone here before we start. I'd like you to think of a number between 1 and 10. And before the presentation is over, you're more than welcome to try to figure out what number in between 1 and 10 that is the accurate one. So what we're trying to do is to go from a seed that you put in the ground to a finished building within 12 months. And what hemp has speaking for it is the fact that you can put a seed in the ground and within 4 months, it becomes 4 meters tall. So it's the second fastest growing plant in the world after bamboo. And it absorbs about 4 times more CO2 than the equivalent acreage or hectare of trees does during a whole year. So in 4 months, it absorbs 4 times more CO2 than the same amount of trees does in a whole year. And what we're using out of the hemp is the hemp hurd, which is in this picture you see it's the middle part of the stalk. So it looks very much like a bamboo. It's hollow in the middle. It has hemp fiber around the outer part. And this hemp fiber is very beneficial, can be used as for textile or for bioplastics. But about 50% of the plant is the hemp hurd, the inner part of the stalk, and that is what we're using. And if it's not used for buildings, it is used as a horse bedding most commonly. But the hemp plant, all of the plant can be used. The seeds are a so-called superfood. So the seeds can be used for either animal feed or for humans. And it's a perfect mixture in between omega-3, omega-6, and omega-9. The fibers are some of the world's strongest fibers and can be used as textile or bioplastics and even batteries or superconductors. And the waste product, the hurd, is what we use in the building. So hempcrete is basically a mixture in between the hemp hurd, the inner part of the plant, a mixture of different limestone, so mainly air lime, which is very similar to what the Romans used, and a certain amount of hydraulic lime mixed with water, and it is a self-bearing but not load-bearing, so you need a wood structure. So in total you have 4 components to build an outer wall, to do an insulation of floors, walls, or ceiling. And it becomes extremely energy efficient. And one of the reasons it becomes very energy efficient is because you can build a monolithic structure. So one structure that can cover the whole entire surface and avoid cold bridges. Another big effect is the cold wall effect. So when our perceived temperature indoors is the temperature of the wall plus the temperature of the indoor climate. You put those together and divide it by 2. So if you have a very cold wall, you need a warmer indoor climate. If you have a very warm temperature inside and you have a cold wall, it will make it feel cooler. And the interesting part about hempcrete is that it has a 70% energy efficiency in the European climate. This is by French studies for colder climates. However, even in Australia, where it's when they had about 40 degrees Celsius, the perceived temperature indoors without air conditioning was about 25 degrees. And this is due to the fact that it insulates both against heat and against cooling. Another very beneficial part of hempcrete is the fact that it is a bio-based material that doesn't burn. So this is a picture from a test that was done on a 2-story structure. And again, it had a 4-hour fire rating. So the reason they say 4 hours is because after 4 hours, they turn off the machines. It is completely uncombustible, which is quite interesting in today's climate, especially with wildfires around the world. So the second largest market for this material outside of France is Australia, and that is due to the bushfires that they have there. But picture says more than 1,000 words. So these are 3 pictures from an automotive garage in central France, where 3 of the walls were constructed of modern materials and 1 wall was constructed out of hempcrete. As you can see from these pictures, the 3 other walls are completely burnt out. There's nothing left of them. The hempcrete wall has been damaged on one side, but from the side that was protected from the fire, you can barely tell that anything has happened. So this is why we're getting a very big interest from places like California and most recently Canada and Hawaii. Another interesting part, as I said, was the fact that you can do both walls and roofs and floors in it, creating one monolithic and fireproof structure. So this is a picture from the Tarn region in southern France, where we were doing both the walls and the roof in the material. And the way we're looking at it is creating bio-based materials to an industrial standard. So being in Sweden, we can only use this material from April to September if we're working in outdoor conditions. However, by doing prefab panels, it allows us to work all year round and to be much more efficient. So this is a picture of a wall that we did together with Gothenburg City and Rice Research Institute in Sweden. And we have created a couple of buildings in Sweden. This is one on the west coast of Sweden that was about 180 square meters and where the walls were assembled in 1 day. So obviously we had to work inside a factory before then, but once they were ready and dry, it's basically plug and play. And the reason we call it a hyperlocal economy is what we're looking to do is to grow hemp, to source lime locally, produce and sell all within a 300-kilometer radius. because you guys are located in Copenhagen, I chose Copenhagen as the outlier, not only for that, also because Sweden will be opening their first hemp refinery just across the bridge outside of Lund in Sweden. So within this 300-kilometer radius, we'll be able to produce hemp, source local lime, and produce the panels. And we have about, at least from a rough estimate, around 10 million people living within this 300-kilometer radius. From Gothenburg up north to Hamburg down south. And finally, just some pictures of some projects that we've been doing. This is the world's first hempcrete house within a greenhouse, a so-called Naturhus. It was done in 2020 and won an architecture award in 2022. And as I said, I just recently got back from Norway, and this is a rendering of Norway's first hempcrete house that we just did in the last couple of weeks. And with this, I'm happy to take any questions. I hope you were able to follow along on this cell phone journey. And if you have any questions now or in the future, I'll be happy to take any questions you might have.
Yes, thank you very much, Peter, for your presentation. And it was very insightful, especially, I'm going to ask the question that probably many people want to ask. Is this the same type of hemp that can be used for medicinal or recreational purposes, or is it a special type of hemp?
It is industrial hemp. So
yeah.
When you say medicinal, you have marijuana that you get high from, which is a sister or a cousin plant of industrial hemp. But then industrial hemp has CBD in it. So what we're using has no THC. It's nothing you get high from. However, the seeds in the industrial hemp plant has CBD, which also has benefits. However, the plant we're using is nothing that is illegal, nothing you get high from.
And before we go into the questions in the chat, one quick question. So in terms of climate, can you grow the industrial hemp in different climates, or is it more suitable for the climate that we have here in the Northern Hemisphere or around the Nordic countries?
You can grow anywhere except around the equator, except anywhere where you have desert climate. It's too dry. Aside from that, from southern Spain to northern Sweden or New Zealand to Kenya, it will work anywhere where it's not, as long as it has sunshine and some water, it will grow just fine.
All right. We
Great,
have some questions popping in. We have one question, Peter, from Stine. Do you use fertilizer and pesticides? And Stine is also asking, do you need to irrigate?
You do not need to irrigate.
Could you hear that, Peter? I think I'm on echo.
I think that maybe someone's
computer
or something.
Yeah. Should I repeat the question, Peter? Yeah. Okay. So Stine, she was asking, do you use fertilizer and pesticides? And do you need to irrigate?
You do not need to irrigate. And you do use some fertilizer. You can use natural fertilizer. But if you want it to grow, if you want more, you don't need to use fertilizer, but it is commonly used.
Right. Then Nils is asking, how do you deal with availability all year round?
You grow enough hemp to be able to store it. So 1 hectare of hemp will be enough for about 100 square meters of hempcrete wall. So that's an idea what will be grown in.
Maybe you can repeat the last bit, Peter.
About 2,000 hectares to begin with, so that will be enough for about 200 houses. There's no problem.
Peter, could you quickly repeat the answer to your question? You were breaking up, so we heard only half of it.
You can store enough hemp to use it all year round. You don't need to have any shortage of hemp or lime.
All right, thank you.
Yeah. Do you want to make the last question? Then
The last question, we can make that. So, Peter, do you know of hemp varieties where harvest time is optimum for both seeds and fiber quality?
It depends on where in the world you're growing, but there are many different varieties of industrial hemp seed, and there are many so-called dual crops that will give you both hemp seeds and hemp fiber. I'm more than happy to put whoever has a question about growing hemp in touch with what I consider the leading experts in the field when it comes to industrial hemp varieties. It's a cooperative that's been around since 1965 called Hempit. It's a French company, and they provide hemp seeds around the world. And they're extremely knowledgeable about what varieties grow best in all corners of the world.
Very well. So thank you very much for your participation. Again, we could stay here for a long time talking to you about this, but we will thank you for your participation, and we will welcome our next speaker. So Peter, thank you very much, especially for with the connection that you said that you might be it's challenging for you today. So thank you very much for making the effort and joining us anyway. So we will now.
Thank you for having me.
What was the number?
Anyone who has any more questions? The number was 4.
The number was 4. Okay. So
oh yeah, that's
4
true. I forgot. I had guessed 7. So okay. Thank you very much. Perfect. Thank you, Christian. So now we will welcome our next speaker, or pair of speakers, should I say, Eduardo and Antonio Carlos from Mush in Brazil. So feel free to share your screen, and thank you for joining us today. The floor is all yours.
Hello, everyone. Just please confirm if you're seeing my screen.
Yeah, we can see your screen, and we can hear you well.
Okay, so it's very nice. Thanks for the invitation to share with you about Mush. We are a Brazilian startup working with mycelium technology, and we combine nature and science in the benefit of humankind. So I just would like to begin with this shocking portrait of our world today. So we have in mass more anthropogenic material, which is those produced by man, than biomass in the planet, even though we are just a small fraction of the global mass. So it's very clear that we have to rebalance this to guarantee our own survival. So we have developed a patented technology that transforms agro-industrial wastes into new material, causing positive impact in the environment. We are not enough happy just making zero impact, so we work to make a positive impact to regenerate our world. But how we do it? We use agro waste as nutrient and support for the growth of a specific fungi. During growth, this fungi works as a natural glue. It unites the particles of the substrate and forms a new material. Our technology is really zero waste. We use a very little amount of water to produce our materials, and we can capture 1 kilogram of CO2 for each kilo of mush material. And the final material has a lot of special properties that we can explore to produce materials that replace traditional petrol-based ones. So we do this at the very beginning of our company in partnership with famous Brazilian designers to create new products and show this technology in our country. So I will just give you some examples. We began working with acoustic material to improve life quality in closed environments. So in the roof, it's a roof covering made with our technology. These are some acoustic clouds. And we also developed some acoustic lighting for the Brazilian market. We also work with decoration. So we made this project for children. The stars and the moon, they glow in the dark. So the idea was to encourage the relationship of children with sustainable material. So we can grow the new generation getting in touch with this kind of materials and stimulating them to do this. We have also developed some sacred art. This is funny because sacred art was always made with the noblest material of its time. And now it's the time of the sustainable material. So this is a provocation that we made to the Brazilian market. We have also developed some furniture, pots for orchids, and also this biodegradable funeral urn that biodegrades in the sea, in the ocean. So I'm sure that this is some kind of message that many of us would like to live at the end of our life. So the work we did in this area of architecture and design is part of a brand positioning strategy. Brazilian market is very new for the population. This kind of material is very new. So at the same time, we know that the Brazilian market is very thirsty for solutions in the area of packaging and civil construction. So these are the areas that we see that we can grow, we can scale up, and cause the positive impacts that we dream of. So we have raised already some investments, and now we are building a factory here in the south of Brazil to start meeting demands in the packaging sector. We have a proof of concept with a very big company from the cosmetics sector here in Brazil. So we are very happy that soon we will put the first packaging material made with mycelium in Brazil. And Brazil is a very large country with a very big population and a large demand on sustainable packaging. We have already a growth projection for the coming years. So you can see that year by year, we want to focus in packaging and construction and not in architecture and design as we did till today. And this growth, it considers the investment scenario here in Brazil, which is very, very different from those you are used in Europe and the US. But you can see that our main goal is to work in the packaging and construction sector. So we invite you to access the QR code. We have an institutional video in English, so you can see our work. And I also leave my contact for those who want to talk later. I'm available for questions if you have now.
Thank you very much, Eduardo, for sharing with us this portfolio that MASH has that is made from biomass that today is considered, much of it is considered a secondary product but it's gaining traction and it's becoming mainstream. We are going to start with a question from the audience, and then I have a couple that maybe I will be able to put in at the end.
Yeah. Good idea. Okay, Rasmus is asking thoughts about land use, area for agriculture restricted.
Okay, yeah, Brazil is the third largest agriculture producer in the world. So we have a lot of agriculture here, which at the same time generate a lot of agriculture wastes. So for example, for each ton of grain you produce, you generate 2 tons of agro waste. So we have a lot of agro waste in Brazil that we could explore for packaging and building. So we are not producing our own raw material. We're using those that are generated in the field in Brazil.
All right. And Michael is asking, so will you run both the packaging and the design business units in parallel?
Yeah, the fact here is that our technology, it's very versatile. So we grow our material in molds. So the final material, it has the same format as the mold we use. So this is very easy for us to change the design of the product. Obviously that when we work with customized projects, we have problems in scaling up. So that's why we began with outdoor works here in Brazil to show the material to people, to make our material as a desired object. So people get to know it, get to test it, put in their home, and get in touch with this material. And now we are moving our goal to the packaging and building sectors where we have a huge scale and we can grow as a company.
All right. And last question right now is from Rasmus again, and he's asking, what is agro waste used for today?
Okay, here in Brazil, most of the agro waste is just left in the field, but many of them are processed in agro industries. And we have many agro industries here in Brazil that pay environmental fees to put away this agro waste because it's a lot, it's very huge amounts of waste. So in our business plan in the future, we would like to get paid to give away the agro waste. We could generate credit carbons, and we can have a final product to sell. So this is what we want to do and became a very circular company.
I have lots of questions as well, but maybe something I'd like to ask you is how do you see, and you touched upon it in your presentation, but how do you see the acceptance of the Brazilian market to these products today?
Yeah, today people are concerned if it works or not. Many people, Brazilian people, we don't eat mushrooms and we don't see fungi as a very nice thing. Rodrigo knows this a lot. So we have to convince people that it's okay, that fungi are not bad. And that's why we begin with this very aural and beautiful work to show people, whoa, this is something I never think of. I didn't know that fungi can become so beautiful, so useful. And this is why what we are building in the Brazilian as a culture, okay? It's a very hard work, but we're moving.
Yeah, very well. So I think that, again, for the sake of time, we will thank you for your participation, Eduardo. Thank you very much for presenting MUSH and giving us insights on this market, especially from a Brazilian perspective. So thank you.
Very nice, and congratulations for the event. It's very nice.
Yeah, thank you for that.
Thank you.
And regarding this, I think that we have seen many examples from these 4 companies in 4 different countries dealing with different types of biomass. We've seen different uses for these biomasses, and we've identified both opportunities, so products that we can make from biomasses that today are just laying there, right? So many of them are surpluses, some of them are first uses, and so there are these opportunities, but at the same time, there are so many challenges that we still have to overcome in terms of awareness, or making people believe and see that this is a good thing, not just in terms of using biomass, but also what is it that we are replacing, right? So we are using these products, we are replacing products that today are either made of fossil fuels or non-bio-based materials, which cause higher environmental impacts. And there are social impacts related to it as well. There's a lot of cultural background that sometimes we have to sort of rebuild the culture around it. So there are many things to consider, and there are many different ways or many contributions that we can bring to this large question that we have sort of guiding the webinar series that we want to build. So what does a future market for a circular bioeconomy look like? And we started building a few of these answers today. But relating to that, we still, inspired from all this innovation, we still have a piece of news, which Sarah's going to talk about now.
Yes, because we have exciting things coming up as part of this project. In this fall, we will be launching an innovation challenge that we call Bio-Based Tomorrow. And in this challenge, we invite startups and companies to develop solutions on the problems that we identify throughout PowerBio. And then you can, as a startup or a company, you get the chance to get closer and co-create solutions on these areas of interests that the municipalities and other partners has in the project. And then you can be the ones finding solutions on better ways to collect and utilize local surplus biomass in a good and circular way. And these are the biomasses that I mentioned before. It's the eelgrass and seaweed from the coastlines, it's the straw from agriculture, and it's the grass clippings from the roadside. So we are right now preparing the innovation challenge, and we're formulating these potential areas of innovation. And we would really already now like your input. If you have anyone who could be a potential innovator, or you just want to know more, you can contact me and Rodrigo after this webinar. That would be exciting to hear from you.
Or even yourselves, if you're participating here today and you'd like to be one of the participants of Bio-Based Tomorrow, you're very welcome to do so.
Yeah, so a way to stay part of this conversation and this knowledge sharing is also to become part of our newly launched PowerBio community. Throughout this project, we will share learnings, results, and invitations for future events and meetings. And one of them will, of course, be Bio-Based Tomorrow, the Innovation Challenge. So you can enter the landing page here by the QR code. We will send you a link after this webinar as well. Just to let you know, the content is right now in Danish, but if we, as we have done today, experience a lot of interest from international organizations, we will consider how we can translate maybe part of the content in there. Yeah, but we're happy that you're all here and want to explore this question with us, how the future market look like.
Absolutely.
A circular bioeconomy. Yeah, sorry.
And as I mentioned, so we're exploring this question. And as we said in the beginning, this was a pilot webinar. We had some technical issues. We are very happy that you bore with us. So you're still here, you participated. Thank you for the exciting questions. We had many exciting presentations and we learned a lot from that. We would like your feedback now. So you can use this QR code to access the form. And we want to know basically if you found the webinar useful and if you would like to participate in a future webinar. If we follow this webinar series and we make future webinars. If you'd be interested in joining them, and we'd like to know if you have suggestions of topics that you would be interested in for us to perhaps use as topics of future webinars. It was very exciting to be here with you today. We have to thank you for spending this beginning of the afternoon with us. We will also send you, after this webinar, the presentation, the slides that we had here today. We also asked the speakers if they would allow us to share their slides, and then we'll send those along. We also asked you a question when you signed up if you'd like to share your contact information for networking. So if you answered yes to that question when registering for the webinar, we will also send you a list of the participants who also clicked yes, so you can get to know each other. All right, if you have questions in the meantime, you're also welcome to contact us. So you have our contact information. You can reach out to Sarah or myself. And I think that's our final message.
I think Sarah? So. Thank you for the 4 speakers who shared their knowledge and their good examples today. Really exciting to hear from you.
Yeah. So have a wonderful afternoon, and we hope to see you next time. Bye.
See you.